So now we're going to look at finding the correlation line of best fit and residual for a nonlinear correlation. So anything but a linear correlation. So we'll go through the same procedure. Hit your home and choose your list and spreadsheet, and we're going to look at putting in values for your list and spreadsheet. Here I already have a list in. Now I have for year 75 all the way to 83, and I have costs associated with that. Okay, now at this point, what I want to do before I choose my line of best fit, maybe I should kind of look at the actual shape of the scatter plot. So I can go to menu, and before I do that, actually go back to home, and I'm going to choose the data values basically and look at the graph in relation to that. And on the horizontal axis I'm going to choose year. Again, on the vertical axis I'm going to choose cost. So I'm looking at that and I can see that it almost looks like something quadratic, virtually half of a parabola. So I'm probably going to look at a quadratic function. So I'm going to go back to here, and I can actually choose the line of best fit right now. So as I go along, I can choose my regression, and I'm going to choose quadratic. Now it's saying that there's something wrong with my list. Two or more arguments must have matching dimensions. So I'm going to go back to my list and see what the problem is. So I can go back to home, and I can choose list again, and I can go back to 1.2 where my list is, correction 1.1, and I'm going to see if there's anything in there that's causing an issue with my list. So 1975, 76, 77, 78, 79, 80, 83. Now it is possible that these values here, although there's nothing there, they're little dashes, I'm going to need to highlight them and delete those values. So I deleted the dashes, and that might have been causing problems with my dimensions. I'm saying I had a lot more X values than I did Y values. Okay, so I'll scroll down to make sure that's still okay. Good. Now I'm going to go back, okay, to home, and I'm going to choose data and statistics again, and now I'm going to look at plotting my information again, just to make sure. Okay, now it's there already, and let's see if this works this time. So menu, analyze, regression, and let's look at quadratic, and there's my line. So there's my line of best fit. Looks pretty good. Let's confirm that in fact that it is a good correlation of determination. So I'm going to go back. Okay. Let's drag my equation up. Here's my equation for that particular line of best fit. I'm going to go back to home, and I'm going to choose my list and spreadsheets again and find that list. It's under 1.2 or 1.4. If I keep going, back, there we go, under 1.1, and we're gonna conduct a correlation regression on this. So again, I'm gonna go to my menu, statistics, stat calc, and I'm gonna choose that quadratic regression and see what my regression is. So again, I'm going to hit my middle of my clicker, and I'm going to put year in the independent or X values, and then go down using tab on the graphing calculator. The dependent variables, the Y list. Scroll down, I'm going to put cost in there. F1 for the function, don't worry about that. There are other options of graphing functions other than list and spreadsheets, but we're going to use the method that I show you. Now keep going down. Now you can see it's going to put the values in your E column. We could change this to C if we'd like, so then your actual results will be in the D column. If an error comes back, we may have to change it back to D. So we hit OK. No, everything's fine. So you can see here title, and we have A, B, and C because it is a quadratic function. I have my R squared and then my residual. So my R squared is 0.973807. Now you could try other regressions as well. You can try a power regression if it's there. You can try an exponential if it's there instead, and see if that has a better coefficient of determination. In other words, a stronger coefficient of determination other than 0.9738. What you're looking for is you're looking for the best regression. Okay, so we could even go ahead and try that. We can look at some other regression here, and let's see, stat calculation, and there's cubic regression also, there's a power regression, there's exponential regression, and let's try exponential regression. And we're going to choose the correct independent variable, again year, and then for the dependent, the Y list, we're going to choose cost, and it's going to put it in F2, of course, and you can see your description of your results will be in the E column, because in the D column had the answers to the quadratic regression. So you hit OK, and you can see that it has in the E column again the description of the answers, and the exponential regression, as it's titled up top, doesn't have quite as strong as a regression as the quadratic regression. It's 0.9293. Okay. Okay. Now, if we want to find our line of best fit, we would have to go back to home, and of course data and statistics. We'd have to do another graph, so looking at putting the year on the vertical axis, and of course on the horizontal we're looking at cost. We go to menu and analyze, and we put up a exponential regression, and you can see the equation for that. Now if we wanted to find a residual at this point of either this particular graph, the exponential, or go back to the quadratic, again we go to menu. The graph has to be there with the line of best fit first, and then we choose analyze. We scroll down to regression, correction, scroll down to residual, and then show plot. So now you can see 1975, and the point is described in the residual plot, and the distance is 1.63, okay, from the actual line of best fit. And we go on to 76. The distance here is indicated at 0.18. And we go down the next point, 1977, being the independent variable to that point, it is below the line of best fit. That's why it's negative 0.57.